We're going to practice writing some chemical formulas for these ionic compounds based on the ions that were given. So the easiest way to do this is something that is I call swapping charges. So the 1 plus is going to come behind the chlorine. The 1 minus is going to come behind the potassium, and then we're going to take the absolute value of the numbers. So we're going to get rid of those positives and negatives. And that's going to give me potassium 1, chlorine 1, but we don't write the ones because they're implied. There wouldn't be one if I didn't write it in there. And so the final answer is potassium chloride. So we're going to do the same thing with Mg2 plus and Cl minus. So in this case, I'm going to have Mg2 plus Cl minus, and I'm going to swap the charges so that the 2 comes behind the chlorine and the 1 comes behind magnesium, but for the same reasons, we're not going to write the 1 behind the magnesium because it's implied, and so the final answer is MgCl2. The last one is going to teach us an important rule that we don't see a whole lot, and so if we practice the same rules, I want you to go ahead and swap the charges like you think you should, and hopefully you see or you end up with Mg2Se2, but technically that's not correct. Anytime we have the same number subscript, we are going to take the least common denominator, and in this case the final answer is MgSe because we're going to divide each of the subscripts by 2. It would be the same thing if we ended up with a 3 plus and a 3 minus, or if you ended up with a 4 plus and a 2 minus, you'll always take the least common denominator. It's the equivalent of saying if you were going to make grilled cheeses and you had 4 pieces of bread and 2 slices of cheese, you're not making a sandwich that has 4 slices of bread and 2 slices of cheese. Each sandwich is only going to have 2 bread slices and 1 cheese slice. The next one says, write the chemical formula for the ionic compound formed by these pair of ions. So it's very similar, except now we're going to be looking at our polyatomic groups. So with our polyatomic groups, we are going to swap charges, but we are not going to make any other changes. So when I put the charge and I flip-flop them, I'm going to use parentheses sometimes to protect the group because NH4 is a group and NO3 is a group. And so if I want to, I can use a parentheses to make sure that my groups are protected. So I'm not breaking up the nitrogen and the hydrogens or the nitrogen and the oxygen. Now, sometimes, like this example right here, when we get ready to swap the charges, I am going to not need it. In this case, hydrogen is all by itself, so I can put the 2 behind the hydrogen just like we were doing before, and I don't have to use the parentheses. So it's okay, I could have written this one just like this, and they mean the same thing. They are equal to each other. The next question says, which compounds would you predict to be ionic? So remember, these are going to be our metals and our nonmetals, or our metals and our polyatomic groups, or our polyatomic and polyatomic groups. So we need to look to see whether or not these things are made up of metals and nonmetals, polyatomic groups, and that way we'll know. And remember that if it's made up of nonmetals, that it's going to be covalent, which is not ionic. So in this case, I have barium hydroxide. This is a metal plus a polyatomic group, so this would be ionic. The next one is CH 2O. Carbon, hydrogen, and oxygen are all going to be nonmetals. Remember, even though hydrogen is in group 1A, we actually classify it as a nonmetal. So these are all made up of nonmetals, so no. For the next one, nitrogen, hydrogen, carbon, and oxygen, these are all nonmetals, so no. We've already done this one, but you can practice again if you want. The last thing here is to calculate the formula mass for each compound. What we have to do is remember that for each element, we're going to take the subscript and multiply it by the atomic mass on the periodic table. So in this case, chromium oxide. Chromium's atomic weight on the periodic table is approximately 52, so we can round the numbers up. Most of them are going to be close to a whole number. There are a few exceptions where it's not a whole number and it's not close enough to round, and that would be something like chlorine. And so as you can see here, chlorine, 35.45. We're going to use those numbers all the way out, but sometimes we can round up. So the weight for chromium is 52. I have 2 of them, so I'm going to multiply 52 times 2. And then to that, I'm going to add the 16 for the oxygen. It's technically 15.99994, but that's close enough to 16. And I have 3 of them, so I'm going to multiply that by 3. When I do this, I'm going to get 104 plus 48, which is going to give me a final number of 152. And the units are important. In this case right now, the units we're seeing are going to be called atomic mass units, which often is abbreviated 152 AMU.